Hello and welcome. You are looking at example problems covering tools of geometry and then some reasoning problems. I should probably just put this in parentheses. Reasoning using algebra, solving algebraic equations with some geometry setup. Okay, let's start straight ahead with number one. Given the diagram at right, answer the following questions. So here we have a diagram. There's a line here that runs through the points S, H, R, and K. Or better yet, all four of these points are collinear. Circle all appropriate ways to name segment HK. So here's the segment from H to K. The endpoints are on H and K. The only appropriate way of naming a segment is to use two letters, and those two letters must represent those endpoints, and it doesn't matter what order they're in. So KH right here, segment KH, would work just fine. This says line KH, and line KH would be the line that passes through H and K, meaning the entire thing, not just where the arrows end. This goes on forever to the left and forever to the right. That would not work. This says ray HK. That would be that'd be a ray with an endpoint at H going past K and forever to the right. That does not apply. And HRK almost would seem to work, you would think, because it starts at H, it goes through R, and it ends at K. That is a possible, I suppose that's a possible way to name HK, segment HK. However, we only use 2 points to represent it, so this actually would be invalid as well. The only one, it's weird, I crossed out with green, circled with red, but so this one doesn't apply, only this one does, it's segment KH. Okay, B, circle all appropriate ways to name ray SR. So if you can't see that, that's actually an arrow like that. So it says ray SR. So let's check that one out. A ray has an endpoint at the first letter. And just because the arrow points to the right doesn't mean this goes to the right. However, in this case, it just needs to go through the next point that's designated, in this case R. As you can see, it hits R and it keeps going. So there's your ray. The only other ways to name this ray is to start with an endpoint of S, meaning have S be the first letter, which all of these are true. And then it needs to go through one of these points. And, oh, by the way, it needs to be a ray. So let's cross out the ones that are not rays. This one's not a ray. This one's a ray, but I'll go back to that. This one's also not a ray either. This is a segment. So these three are rays. SH starts on S, goes through H, and continues. This would be valid. SR right here, as you can see, the arrow's pointing to the left. Now, besides the fact that we never point our arrows to the left to indicate rays, even if it's going to the left or otherwise, your endpoint needs to be S. In this case, when it's pointing to the left, what it's saying is R is the starting point, and then it's going through S and continuing on. That's not the case here, nor should our rays ever point to the left. So, just valid. So, in other words, if this said RS like that, this would also not apply. That would be no good. SK right here, ray SK also works because it starts on S, goes through K, and continues on. So these two, ray SH, ray SK, are valid ways, appropriate ways to name ray SR. C, circle all appropriate ways to name the ray opposite RK. So there's a term that's called opposite ray, and what opposite ray means is that, or opposite rays, is that if you have one ray go in one direction, let's say RK, like so, an opposite ray would be a ray with the same endpoint going in the opposite direction, meaning these rays end up being collinear. So I'm going to refer to the blue here. This is the ray that's opposite RK. Ray RK and ray blank blank R something is our opposite rays. So what are they? Well, HS is a line and doesn't start on R either way, so that's not going to work. Here's ray KR, which means it starts on K, goes through R, and continues. It does continue in that direction, but the endpoint K is not what we're looking for. That doesn't work. So we're looking for an endpoint of R and going through a point H or S. So RS looks like it would work. Starts on R, goes through S, and continues. Ray RH starts on R, goes through H. That works. And then line RS would be invalid. Again, that's a line. We're trying to find rays. If you couldn't see that, it's doing that. So that's number one. Okay, number two, consider the diagram on the right. Use the vocabulary words below to complete the sentences by filling in the blanks. Each vocabulary word can only be used once. So there are 7 vocab words, and there are 7 of these, so each one will be used, and I'll cross them out as I go. Okay, angle DYE is a blank angle. So DYE, the way we name angles is we name a point on a side of the angle D, vertex will be Y, and E will be a point on the other angle side. So it can either look like that, or it could be going that way as well. I think we tend to be looking at it with the way that all the other rays are shooting through. However, this is a straight angle. This is 180 degrees. And that name makes sense because it is also a straight line. Now, we name angles with 3 letters. We would not name this line DYE. We'd either name it line DY, line DE, or line YE. Angle OYN. OYN, let's see. O, from O through Y to, oh, there it is, right there, and boom. So this angle right here, it's a small one. As you can see, here's a 90-degree angle. This ray goes through, so it's less than 90 degrees. And it looks like with this, we're trying to find something out with acute. There it is. That's an acute angle. An acute angle is between 0 degrees and 90 degrees. And just for good measure, before I keep going, I'm recognizing the fact that here on the bottom, these last 3, we're looking at angle relationships. So I'm going to go ahead here. Let's use red for that. I'm going to go ahead and say that over here, we are referring to this term, and this term. We would not use these terms unless we were referring to pairs of angles. Angle pairs can have a relationship of being adjacent, complementary, or supplementary. We could also use vertical, but in terms of what we've used so far in the videos I've used, but in this case, we're not looking at those. So anyway, our next 2 are either going to be obtuse or right, because we're referring to it one single angle. So that's what's going on here. I just want to make sure that you're ready so you're not looking through the words that you don't need to yet. So angle NYE starts here and hits Y and goes through at E, like that. Now this one looks like a right angle, but you have to be sure. And the only way I can be sure is I know that this is marked as 90 degrees. And this is a straight angle at 180. So by subtraction, 180 minus 90, you get 90 over here as well. 90 over here. Ooh, ooh. So here we go. NYE is 90 degrees, which makes it a right angle. So by process of elimination, I could say that I now know what angle KYD should be. It should be obtuse, but let's check it out. KYD is this guy right here. It's greater than 90 degrees. It is less than 180 degrees. That is the definition of obtuse. And that does work. So it all worked out there. I'm going to go ahead and erase these. All right. The last 3 here are the relationship pairs that I was referring to, adjacent, complementary, supplementary. Angle NYK and angle KYE. So we have NYK right here. We have KYE right here. They're not necessarily congruent, meaning not equal in angle measures. However, as we knew, angle NYE total was 90 degrees. And the angle addition postulate tells you that if you add up 2 angles, if you have 2 angles that, well, I guess you could say are next to each other, I'm going to use the term next, then they add up to their total sum. So there are 2 things that we could actually say here. We could say that these are adjacent because they are neighboring each other. We could also say that these are complementary. Now, the idea here, I'm going to put them both in because I have a feeling it's going to be complementary. They said everything can only be used once. Now, these are adjacent angles. They have a common side, KY, or YK. They have a common vertex of Y, and they are coplanar. All 4 points are on the same plane that are essentially on your computer screen here. So adjacent would work, but these do add up to 90 degrees. So I'm guessing it's going to be complementary. Let's check out one that will say adjacent, and then I'll cross it out there. Angle NYK and angle NYO. So here's NYK, and here's NYO. It looks like these are the ones referring to what are adjacent. Now, if you tilt your head, you can take a look and say, see, those look like 90 degrees, actually, if you actually tilt your head at an angle. And I don't know if it's perfect, but you can't be certain that that's 90 degrees. There's no deductive reasoning to state something like that. So I can say that these for sure are adjacent, though. Common side, common vertex, and coplanar. So adjacent won't belong here, it'll belong there. And the last one should be supplementary, meaning adding to 180 degrees. Let's take a look. Angle KYD. KYD is green. And angle EYK, also in green, they add up to that straight angle. See, these are supplementary. That is 180 degrees in a pair of angles. And there you go. We've used all 7. Number 3, use the figure at right, given that the entire length of TR is 60. So I know this much. I have segments TW and WR. They do not tell us that TW is congruent to WR, and they do not tell us that W is the midpoint of TR. So make no assumptions there just yet. But what we do know is that these are collinear. These go on the TR is a segment. So if I add the length of TW with the length of WR, I will get the entire length of TR. So what we're going to do down here is work on some 2-column proofs, and by that meaning we're going to make claims. This is the math that we normally do, and the reason behind them will also be applied. So we're going to make sure that we have some reason based on these properties or postulates. Any of these terms or phrases we're going to fill in here. And this is called the segment addition postulate, and what this means is that if you add the length of one segment with the length of another segment that are both collinear, then you get the length of the entire segment. I just wrote what I was saying, postulate. Now, postulates are statements that are accepted as facts. They do not really need to be proved. They kind of just are. Okay, you know what? This is missing information. Let me write that in right now. 5x minus 6 is this length, and this length is 4x plus 3. Okay, moving on. 5x minus 6. So here, if you're, this is built for you, so you should probably make the connection that, oh, look, this is the length, this is the measured length TW of that segment. This is 5x minus 6, and as we had plus the length of WR, this part must be 4x plus 3. I'm just going to group it. And that equals probably the length of TR. What is that? Ooh, that's 60. Right? So what did we just do there? This was straight up what we call substitution, where we replace values for our variables in this particular situation, in this instance. The next part looks like we're trying to solve for x. Now that the geometry kind of stuff is out of the way, if you want to follow these statements along with me, we're going to combine like terms first. 5x plus 4x is 9x. Negative 6 plus 3 is negative 3. So that way you can get to the next step. But what did I do here? I combined like terms, or I used the term simplify. That's what we did. Now what did we do before? Substitution property was what this one was. And this is simplification. Okay. Now we isolate our x term here by adding 3 to both sides, and when I do that I get 63 on the right side. That was using the addition property of equality right there. Addition. I'll just write addition. You saw what this says right here. But it's addition property of equality. All of these are of equality, meaning with an equal sign, this is the property that can be applied. We can add the same thing to both sides, and we keep this equation still true. Divide both sides by 9. You'll get x equals 7. That is the division property of equality. I don't know why I turned to only black here without green. And last one here, I guess you can't really use any of these except if you use substitution again. Let's just say substitution property here. WR equals 4 times 7 plus 3. So WR is 28 plus 3, so it's 31. Okay, yeah, I guess there's no real reason behind that. I think in the end here you solve for x, and if you substitute for x, but I guess they're graying out this reason for us. Okay, number 4. You're given that the length of PT is 8x minus 4, and the length of PQ, the entire thing, is 10x plus 22. They also give you this little part right here. It's not really stated, but it's drawn. These tick marks, 1 and 1, indicate that PT is congruent to TQ. So maybe that's even a statement that I make. So if that's the case, now look, this is kind of like a two-column proof thing here. If you want me to write it like this, if PT is congruent to TQ, then the measure of PT, the length, is equal to the length of TQ. And by substitution, 8x minus 4 is equal to the length of TQ as well. I can substitute 8x minus 4 in for TQ. If PT is 8x minus 4, then TQ is 8x minus 4. Or better yet, whatever PT is, I could double the length, and I get the entire length of PQ. So what I could write is PQ is twice the length of PT. So PQ is twice the amount of 8x plus 4. Or what I could have written was 8x, oh, this is minus 4, I'm sorry, I'm writing plus 4. Or better yet, I could have said 8x minus 4 plus 8x minus 4 equals PQ. Now PQ is 10x plus 22. So this is 2 times 8x, that's 16x, minus 2 times negative 4 is 8. Boom. Subtract, I'm going to subtract 10x over, I get 6x equals 30, and I divide by 6, I'm going to get x equals 5. So you have to work some magic there. You have to understand the congruent part. That's the big step in this that's not said and only drawn. If x is 5, then PT is 8 times 5 minus 4, which is 40 minus 4, which is 36. If PT is 36, PQ is twice the amount of 36, which is 72. Number 5, use the figure at right. You're going to be given some information here that the measure of angle GAR is 5x plus 3. Assume that's, I guess, in degrees. The measure of angle RAT is 7x plus 8. And the measure of angle GAT, the entire thing, is 107. And I guess, again, I guess that means degrees. Now, there's nothing that says 5x plus 3 is equal to 7x plus 8. They don't say that ray AR is an angle bisector. And they don't say that GAR and RAT are congruent. But what you do know by the angle addition postulate is that if I add the angle GAR in red with the angle of RAT in green, then I get the entire angle GAT, the entire angle measure. So I'm going to create that equation. I'm going to write the measure of angle GAR plus the measure of angle RAT equals the measure of angle GAT. So you have all three. Now by substitution, I'll just go ahead and go black. Substitution, we get 5x plus 3 for GAR plus 7x plus 8. I should probably make a habit or enforce a habit with you by grouping these just in case there's something with substitution or doubling up, not substitution, subtraction. I think it would be very important that you make that happen. Equals 107. Combine like terms, 5x plus 7x is 12x. 3 plus 8 is 11. Using the subtraction property of equality, you get 12x equals 96. And I believe you divide by 12, you get x equals 8. If that math is right, I think I still know my division. So if x is 8, let's find the measures of angle GAR and RAT by substitution. GAR will be 5 times 8 plus 3, which is 40, plus 3, which is 43. The unit is degrees. And the measure of angle RAT, you can get it one of two ways. Either substitute for x, substitute 8 for x and solve, which you'll get 64 degrees. Or you could have taken 107 degrees and subtracted 43, and you'll still get 64, because it makes sense that when you add the two up together, you get 107. So if you subtract 1 from 107, you should get 64. And there you go. Okay, number 6, we have a nice figure at right here. So we have opposite rays PRPW and opposite rays PTPO, or better yet, this is a line and this is a line. And when you draw two lines through together and they cross and intersect and pass, you create what are called vertical angles. And vertical angles are congruent. Now they marked it for you, but vertical angles facing opposite each other with pairs of opposite rays are equal. So line TO intersects with line WR at point P. The measure of angle TPR is 55 degrees right there. The measure of angle WPO is 3x plus 7. They might as well tell you that also given is measure of angle RPS, which is 2x. So let's solve for x. So in order to do that, like I said, these two angles are equal. So if these are equal to each other, let's create an equation that says that. 3x plus 7 equals 55. And that's it. Now solve for x. 3x is 48. By subtracting 7, divide by 3, you'll get x equals 16. So the measure of angle WPT, now this is an interesting one because there's no information on it. However, RW is a line. So I could draw this right here. And what do you see with the blue and this red, or the blue and this red right here? What you see is a line being formed by the sum of two angles. So if I add up TPW with RPT or TPW with WPO, you will get a 180 degree angle. These are called supplementary angles. So I could do it either way. I'm going to go ahead and do it with my 55 because it's a significantly easier number to use. However, this should be marked as 55 as well. You know that they're the same thing. So WPT is 180 minus 55, and that's 125 degrees. Okay, I anticipated more work, so this last problem is down here. Let me do the work up here. Given the measure of angle RPS is 2x, let's find the measure of angle RPS. So if RPS is 2x, then measure of angle RPS is 2 times 16, which is 32 degrees. And that's all. In a plane, the coordinates of segment, that's a segment, CD are -7, 9, and 3, -1. The midpoint is blank blank. So this is what we're trying to find. All right, there are two ways to go about this. I'll go ahead with the graph version first, so you get a very visual example of what's going on, and then I can explain it as we go over the midpoint portion, the midpoint formula portion. Now this is going to be a very roughly drawn graph. I'm not doing too much with it here, besides those very nice looking lines. So I have to go 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Doesn't have to be perfect. I just need to make counting out of something here. So that's point C, and then point D here is at 1, 2, 3, and -1 right there. So points C and D, this is a segment that I can draw through to get this right here, and I'm trying to find the midpoint, the halfway point from one to the other. Some people believe that if you find half the distance, you could then use a counting measure to make that happen, but it doesn't really work because you can't count going this way unless you go vertically and horizontally. So what I'm going to do in a graphing sense is I'm going to count how far down I have to go from C to D in terms of height. So in other words, just going straight down here from 9 to -1, right? This is -7, 9. From 9 to -1, how far down did I go? Well, 9 is, so 8 is 1, 7 is 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to go down 10. You could put -10, but it's all good. And going over, how far did I have to go from -7 to 3? From -7 to 0 is 7, 0 to 3 is 3, so total is 10. So you go down 10, you go over 10 to get all the way to that other point. So what I want to do in finding the midpoint is basically divide these lengths in half and then just go halfway. Going down 1, 2, 3, 4, 5 instead, boom, and then going over 1, 2, 3, 4, 5, and this isn't perfect counting, but the idea is that you have to either take this number, I guess I might as well take this number, and to find my midpoint, and it's going to be adding 5, going 5 to the right from -7, and going 5 down from 9. That's going to give me the midpoint there. You could actually count it, but I'm just going to give you that math, and it's going to give you the points -2, +4. So you're still in the second quadrant, and that's something that's probably to be expected. Okay, second way to go about this problem is by using the midpoint formula. And that formula is so that you take the average of your two x values and divide by 2. And then you take the average of your two y values. You don't take the average and then divide it by 2. Taking the average is dividing it by 2. And anyway, so in doing that, you take your two x's, -7 and 3. This is 9 plus -1 divided by 2, which is -7 plus 3 is -4. -4 divided by 2 is -2. 9 plus -1 is 8. 8 divided by 2 is 4. So you still get the same midpoint there as you got there, as you should. Okay, in a plane, segment FG has one endpoint at F, which is 4, 10, and a midpoint at 6, 7. The coordinates of endpoint G are blankety blank. So this is another midpoint question, but in this case, you actually now have the midpoint, and you have one of the endpoints. I'll call this one x1, y1. And we're missing x2, y2. So we need to find that one out. We have the midpoint. So if I were to do another graphing one, what I need to do this time is I need to find the other points. So I'm at the, let's see, 4, 10, and 6, 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close enough, way up there. That's point F. Midpoint is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And there is midpoint. And where to find G? Now the good thing about graphing is you can get a basic idea of where you think it is about. I know mine should be in the first quadrant somewhere. I think the x value should be larger, the y value should be smaller than both F and M. As you can see, M should be the midpoint. I'm not saying I'm finding out the answer doing that, but I can use that to say that my number should be positive and this and that. Yeah, I know what to expect in case I do any wrong math. So as I go down and over to the midpoint, because I know these values, I'm going from 10 to 7 in the y direction. So I'm going down 3 to get to M. Now going over from F to M, I'm going from 4 to 6. So I went over 2. So think of this as if you're calculating the slope of something. You're going down 3 over 2. To find G, I have to go down 3 again and over 2 again. So this is like, to get the next point because these are collinear. So from point M, let me put -3 to say that I'm subtracting. So from point M, I'm going to take 6 and add 2 to it. I'm going to go 2 more over in the x direction. And I'm going to go 3 more down in the y direction there. So I should be at the point 8, 4. Okay. If you want to do this a different way, what you could do is the midpoint formula, but this one gets a little more complicated because what you now have to do, the midpoint formula is up there. So your midpoint is 6, 7. So that midpoint is equal to, x1 is 4, so I'm going to do 4 plus the unknown x2 over 2, and 10 plus the unknown y2 over 2. Okay, now in this case, 4 plus x2 over 2 is equal to 6. This is my x coordinate for my midpoint. So I'm going to create brand new equations, and there'll be 2 new ones. So I have 6 equal to 4 plus x sub 2 over 2. And then I have one for my y value. 7 is equal to 10 plus y sub 2 over 2. I know there's kind of a lot of scratch work, so I'm apologizing for that. If I multiply both sides by 2, I can get rid of that fraction down there, that unneeded one. 2 times 6 gives me 12. So here, I'm going to get 12 is equal to 4 plus x sub 2. Subtract 4, you'll get x sub 2 equals 8. Now, as we already got, as shown up there. And here, if I multiply both sides by 2 again to clear that fraction right there, 2 times 7 is 14. So we got 14 equals 10 plus y sub 2. Subtract 10, y sub 2 equals 4, as you get right there. Kind of chicken scratch, but it's all good. Okay, numbers 8 and 9, we have this rectangular prism. Assume that these are all right angles. It might even say that somewhere. Here we go. All intersections are at a 90-degree angle. We have a few planes, 6 faces, and a bunch of edges. Now, planes go on forever, so as these intersect, this GH is not just a segment, it's also a line. So this would go on forever, just as these planes do. Just these are the points for which these four planes or 6 planes or whatever intersect. Okay, line HG and line GL. So the one I just drew on, HG and GL are blank lines. Boom, 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 boom. What we're trying to do is use one of these, I guess, 4 terms: perpendicular, skew, coplanar, or parallel. These lines intersect, so they're definitely going to either have to be perpendicular or coplanar. Skew or parallel do not intersect. And these intersect at 90 degrees, as this below says. So these are perpendicular lines. Okay, that's the first one. Next one is line GH, once again, and line PN. Here's GH, here's PN. Now, there is a plane which I can draw, and if you can kind of imagine what I'm doing here, I'm going from G to P, and I'm doing another rectangle here, and I'm going from N to H, or about that area. It's like a ramp going through. You can draw lines on the same plane even if there's not a plane being drawn through it yet. Well, I just drew one. These ones don't intersect. These ones are on the same plane together, so these ones are parallel. Even though they might not really look it, think about where you're sitting right now. Hopefully you're facing a wall. Go ahead and look up at the very, where your ceiling meets the wall. You're basically, like, think of that as line GH. Think of you being right here. You're facing this wall right there at your computer screen. Look up. There's line GH. Now look behind you. If there's another wall behind you in the corner, that's line PN. Those two lines are parallel to each other. That's where those two meet. So we've got those two out of the way. Maybe the two easier ones. JN and GK, well, easier as far as maybe you know the definition more. JN and GK, here's JN, here's GK. These lines are not on the same plane with one another, and these will not intersect. Even if this line goes forever that way, this isn't touching this other line. It's in the background. You have to get that 3D perception that they are not together with one another. These are called skew. Skew lines are not coplanar. They do not intersect. So while parallel lines also don't intersect, these have to not be on the same plane, and those weren't. Okay, so I'm noticing something about this very last one here, and this last one I'm seeing this plane HGK and this line MN. Now these are not coplanar, right? If they're coplanar, then this line would be on this plane. This line will never intersect with this plane, so this answer is parallel. So what's interesting was I kind of jumped ahead and said automatically this one must be parallel and nothing else, line GH and PN. So let's look back at that one. Remember what else I said about these two being parallel? I said if they're parallel, they are on the same plane. I even drew that plane for you. If they're on the same plane, that also makes them coplanar. So if these can only be used once, then parallel was used down below because they were not coplanar. So this would have to be coplanar up here, and that would have to be parallel. And that's maybe your process as you're taking an exam, right? You notice that afterward and you correct your own mistake. Okay, number 9, use the same diagram as number 8 and name where the following intersect. Here we go. Let's do plane KLP. So KLP is the one, it's this front-facing one. And the line GH. Okay. There we go. Now remember, this plane still goes on forever. It keeps going on that way, but you still see the intersection point. This line goes through the plane right there. That's just one point. Point G. Point G. A line will intersect a plane at only one point, unless the line is on the plane, in which case it intersects at every point. Okay, plane KPN and plane GHJ. GHJ is over here. KPN is an interesting one. It goes through the bottom right there. So you now have floor meeting wall. And if you look, there's a line that's going across there. That's this line KJ. Remember, the plane goes on forever. So there we go, line KJ. Okay, number 10, this is all about Pythagorean theorem. In a right triangle, there's a relationship with the legs, which are the two shorter sides, and the longest side, which is called the hypotenuse of it, such that if you take the sum of your squares, you get the square of the longest side. So we can solve for the distance of one of the sides using that just by substitution. Okay, this one I can solve in two ways. Here I'm going to substitute, get x squared plus 12 squared equals 15 squared. X squared is now 15 squared minus 12 squared. Now let's start squaring these guys. X squared is 225 minus 144, which is 81. So the square root of 81 is 9. Now the answer really should be 9 or negative 9 if you're referring to something more algebraically, but we are referring to distance, and distance can only be positive. So your answer is 9. I said there were two ways to solve this. The second way is recognizing what kind of special triangle this is. In fact, B is also a special triangle, something you might not know yet. But this is called a 3, 4, 5 special triangle, and all that means is that there's a ratio of these sides that are all integers in these right triangles, such that if you keep doubling or tripling these numbers or whatever, you will get this known side length. And if you recognize that, you can probably solve for it immediately. As you can see, 9, 12, 15 as a part of the 3, 4, 5 relationship. This is another one. This is called a 5, 12, 13 special triangle, so I already gave you the answer before you know it. But you still should probably use Pythagorean theorem to show your work to solve for it. So I will do that anyway, and we get 13 or negative 13, but as we know, distance is positive. This is just 13. Okay, find the distance between the 2 points to the nearest tenth. I have points 3, 2 and negative 7, 5. So I'm going to go with the graphical approach first, just like I did the midpoints. We'll talk about that. Now, the reason we did the right triangle stuff just before it is being included for what we're doing here with distance. So 3, 4, 5, 6, 7, 3, 4, 5. Okay, so I have the points 3, 2 and negative 7, 5 right here. And I need to find out what the distance is between them. Okay, so just as we did midpoint before, with the graph I started by counting how far down did I have to go from basically 5 to 2. 4, 3, 2. That's 3 points down. Or 3 units down. How far over from negative 7 to 3? Negative 7 to 0 is 7. 0 to 3 is 3. 7 plus 3 is 10. So what we make here with the vertical and horizontal little distances, dotted lines, are a right triangle. So this is just like Pythagorean theorem here. We're going to do a squared plus b squared equals c squared. And solving for that, we get 9 plus 100 equals x squared. And x squared is 109. So x is the square root of 109, and in the calculator, that becomes 10.44 units. Now, they said round to the nearest tenth, so I gave you that other decimal to show that if I round down, it should be 10.4 units. So there's your distance. How else could have I done this? Using the distance formula, and that's what I'll do for the next one to save time. So this one I did not use distance formula. This time I will. Now the distance formula is derived from the Pythagorean theorem. I do have a video that does discuss that. I think it's called the coordinate plane. I think that's the name of the video. And you can find how this formula comes to be from the Pythagorean theorem using right triangles. But the idea is you find the distance between your two x values and the distance between your two y values. And the only way to find them is through subtraction. Even if some of them are negative, that will actually increase your distance when you subtract. So here, I'm going to call this x1, y1, and this x2, y2. We're going to get negative 7 minus 6 quantity squared plus 1 minus 0 quantity squared. Negative 7 minus 6 is negative 13. Now, if you're having trouble saying, well, wait a second, distance can't be positive, don't worry, we're going to square these values. And when you square negative 13, you will get positive 169. 1 squared is 1, so d is the square root of 170. So D is about 13.03. Rounded that down 13.0 units. Can't fit units there. And there you go. There's that distance, about 13. Okay, we have two more problems. They both involve a compass, so construction. Do not erase any arcs produced by your compass in exercises 12 and 13. So number 12, we are going to use a straight edge and compass, construct the angle bisector of PQR. So something that's going through like, like that, but dividing it in congruently. Now P and R are not the same distance from Q. That's important to note because you don't want to accidentally use those as reference points. You have to use your compass and actually draw your own arc to make this happen, to make two congruent points away from there. So the way that you do this is you start on your vertex Q with your pivot, and you draw an arc that passes through the sides QR and QP so that they are congruently distant from, congruently the same distance away from Q, as P and R were not, so we couldn't use those. Now what you do is you take this, and you can change your arc to whatever width you need. I'm just going to leave it as is. What I need to do is draw an arc that's now going through the middle with this pivot right here. Now I'm going to take the pivot over here. I'm going to draw another arc that goes through the middle. And what's going to happen is these are going to intersect at some point. That point, I can't do this. That point will be right in the middle of, it's right between these two sides right here. And that's where you create your line or your ray using a straight edge. I just have my line tool that goes right through, and that will bisect your angles. And I'll leave those there. That gives, if I call this point S out here, that makes angle PQS congruent to angle SQR. And there you go, created an angle bisector. Okay, the last one is we need to create a right triangle with legs that are congruent to segment AB and CD. Now, a right triangle with legs, meaning these will be the two shorter sides, and the hypotenuse will just be made from what we use here. Now, this isn't maybe something that you've done yet, at least according to my videos here. So I'm going to start by making a really long line segment. You would do this with your straight edge. I'm going to make a perpendicular bisector here because you need to make a perpendicular line at some point. You need that right angle for this right triangle. So I'm going to stretch this out past its midpoint. I know that that should be past it. Make an arc on this side, and point here, and make an arc on this side. So the first part is to make that right angle, just like that. Now I'm going to make a segment that goes through there. So I'll just first draw the segment. That was actually pretty good, but I want to make that line a little bit to the left and thin it out. And that looks okay. Okay, now I've made two long line segments with that perpendicular angle. Now all I need to do is get these lengths of AB and CD. So, if you can imagine, I'm just looking to get AB's length with my compass, and I can start from the perpendicular bisector, the actual point, and mark off where it's going through. So for instance, right there, from this point to this arc intersection is like the length of AB. And I should do the same thing with CD. So again, swiveling on through, only because this compass is tough to work with on a screen. I shrink it, and I figure out it's about right there. This length here, this compass width, will be marked off right here for CD. Right there. So the two intersections right there will be the lengths, and I now can make my width, or my hypotenuse, right there. So see what I just did here. Now I'm not erasing anything, but I will highlight where the right triangle is. This length is CD. This is a right angle right here, and this length is AB. Those are the legs and the hypotenuse right there. So we started with a perpendicular bisector, and it needed to be wide enough that you could actually now extend that to AB. And this needed to be tall enough that you could extend it to CD. Fiend!